Okay, so another mechanics question, we've got a slope. So a cyclist is moving up a slope that is at an angle of 90 degrees to the horizontal. The mass of the cyclist and the bicycle is 85 kilograms. Calculate the component of the weight of the cyclist and the bicycle parallel to the slope. Some of you didn't even understand what that meant. Basically, just like the previous doubts, the previous video that I've uploaded, the previous question, we've got some force which is going downwards, which is our weight. However, since this is a slope, that force will actually only drag this cyclist down along the slope. So what we have to actually find is the component of that force which will be along the slope. So we have to calculate the components, right? So if we draw, for example, a free body diagram of that cyclist, now we would have this, there would be this weight, and we would have to split that into a force, a component which is along the slope and another component which is perpendicular to the slope. Now, since our angle here is 19, this angle here is 19. So if this angle is 19, this would be mg cosine of 19, and the force down the slope would be mg sine of 19. Therefore, the force would be mg sine of 19, which would be 85 kilograms times gravity times sine of 19. So, check shift setup, it's in degrees, that's fine. So 85 multiply 9.8 multiply by sin of 19, 271. So the follow-up asks us about the normal reaction force on the bicycle from the slope. So now we're looking at the normal reaction. So it's the force which is perpendicular to the slope and is preventing this cyclist from going through the floor. So since the forces on this direction here have to be 0, the sum of the forces is 0, I will have that my normal force has to be equal to the component of my weight. So it will be mg cosine of 19. The forces will have to be in balance in this direction here, which is perpendicular to the slope. So if we calculate here 85 kilograms times 9.8 times cosine of 19. There you go. So we've got 787 newtons. Now notice that for this question in particular, the mark scheme is accepting for values if you instead of using 9.8, if you use 10. So often they will accept those, but I would just highly suggest that you use 9.8. Okay. So following from that one, we've got that at the bottom of the slope, the cyclist has a speed of 5.5 meters per second. The cyclist stops pedaling and applies the brakes, which provide an additional decelerating force of 250 newtons. Determine the distance taken for the cyclist to stop. Assume air resistance is negligible and that there are no other frictional forces. So, before we measured our component of weight to also be trying to stop the cyclist from going up the slope. And this was given by mg sin of 19, which we calculated to be around 271 newtons. But now, besides this force, there is another force of 250 newtons, because the cyclist has braked, he's braking. So that's an additional deceleration. So we know our initial speed, which is 5.5, and well, we know some forces. We want to know when it's going to stop, so final velocity, we know that it's 0, and we want to know the distance, the displacement. Now we can get the acceleration using Newton's laws and the forces that we have here. So the sum of the forces should be equal to mass times acceleration. In this case, it's the velocity is changing, right? The speed is changing. Therefore, the sum of the forces will not be 0. It's not balanced, and it's clearly not balanced. The sum of those forces will be the sum of the forces that we have here. So it's 271 newtons, which is bringing it down the slope because of its own weight, plus 250, which is a bit of effort, more effort that the cyclist is putting to brake. So he's pressing the brakes. If you add those up, you should have 521 newtons. However, I know the mass of my cyclist, which was 85 kilograms. So if I rearrange this equation, I would have that the acceleration will be this force, the resultant force, divided by that mass. So I can just take 521 newtons and divide by 85 kilograms. So 521 newtons divided by 85 kilograms is going to give us 6.13 meters per second squared. Now, it's important to notice that I've completely ignored the signs here, because I know for sure that this acceleration is going to be in the direction down the slope. Okay? If you were to calculate, if you were to decide upon a frame of reference, if you decide, for example, for your frame of reference to be positive in the direction of going up the slope, then this acceleration would be negative. I am going to assume that this is negative. Why? Because my initial velocity has been presumed to be positive. So since my initial velocity is positive and I'm going up the slope, I'll just assume that this is negative going down the slope. And those forces, they would be negative because they are in the opposite direction of our motion or of our frame of reference. So this would be negative. Well, now it's our motion laws. We know initial velocity, we know final velocity, and we know acceleration, which is negative 6.13 meters per second squared. Now we can pick some of our CUVET equations to solve this. What I would do, I would pick final velocity squared equals initial velocity squared plus 2 times the acceleration times the displacement. Since I want to know the displacement, I'm going to make it my subject. So I will have final velocity squared minus initial velocity squared divided by 2 times the acceleration. Final velocity, 0. Initial velocity, 5.5. So here we can see that we've got a negative sign on front of that, which will cancel out with the sign of the acceleration, since the acceleration is negative. So over negative 2 times 6.13 meters per second squared. I'm not putting the units here because you can see that velocity or speed is already in our SI units. Acceleration is already on our SI units. Everything is in SI units, so I don't have to worry about it. I know that my final displacement will be in meters. So if we calculate this, 5.5 squared divided by 2 times 6.13, notice that I haven't put the signs because it's pointless. So we would have something around 2.47 meters, which is not that much.